Hello everybody and welcome back, and thank you for joining me as we finish off the 2006 Galois paper. So we're on question number 4. Hopefully you've given it a try. Let's take a look together. So it's a 3-part question, and we've got no definitions. I'm used to, on a question 4 on a Galois or Hypatia, giving us a brand new definition at the start, but we're just jumping right into it. When the number 14 has its digits reversed to form the number 41, it is increased by 27. Determine all 2-digit numbers which are increased by 27 when their digits are reversed. Okay, so we're talking about 2-digit numbers. And so I can write any 2-digit number. We do have to, this is written solution contest, so let's say we can write any 2-digit number as 10a plus b, where a is somewhere from 1 to up to 9. I don't allow the digit 0 because it's got to be a 2-digit number. But b can be anything from 0 to 9, single digits. Okay. So this is, I mean, technically this would be written as AB, but we don't want to confuse that with A times B. So it's A is the tens digit, B is the units digit. Okay. So we're talking about reversing the digits. Well, when I have it written out like this, it's very easy to reverse the digits. When we reverse the digits, we get 10b plus a. And we want to have increased by 27. So we have 10b plus a minus the original number, 10a plus b, and we want that to be equal to 27. All right. Well, what can we do here? 10b, I'm going to group the tens together and the units digits together. And we can take out, actually no, I don't think I want to do that. Let's group, we'll group the A's and the B's together. So 10B minus B is 9B, and then A minus 10A is minus 9A. There we go. So this will be 9, B minus A is 27, so B minus A must be equal to 3. That's the only condition, and any number that satisfies this will work, because then we'll put 3 in here, and then we'll be able to express it this way. So we just need to list out all possibilities where A and B are A plus 3 is equal to B, and it's a short list, so we're just going to write it out. So we see that 1, 4, well, hey, 1, 4 is the one that they tell us about. So 1, 4, 2, 5, 3, 6, 4, 7. I'm picking a single digit here and I'm adding 3 to it. 5, 8, 6, 9. Now, when I would go to the next one, I'd get 7. Add 7, you'd get 10 here. So do we put a 0? No, we don't do anything. There is no single digit B that when I subtract 7, I get 3. So these are the only ones that work. You can check that by picking one at random that they really do work. Let's try 47. Reverse the digits, it's 74. 74 minus 47. 74 minus 40 is 34. Minus another 7 is 27. So yeah, it really does work. Okay. And we'll just finish it off with are all such numbers. That's a fine way to say it. The important thing is that we get the numbers listed out properly. And we have our reasoning to explain why it's those numbers and only those numbers. So we can move on to B part. Choose any 3-digit integer. They've got some underscores here. That's okay. A, B, C, whose digits are all different. When we write a number in terms of its digits, we mean the 100A plus 10B plus C. So exactly what I was doing, but they're using lowercase digits. That's fine. Reverse the order of the digits to get a new 3-digit integer, CBA. Subtract the smaller of these integers from the larger to obtain a 3-digit integer, RST, where R is allowed to be 0. Okay, that's interesting. Reverse the order of the digits of this integer to get TSR. Prove that no matter what 3-digit integer we start with, RST plus TSR will be 1089. Interesting. Very interesting. Okay. What can we do? Well, I think breaking it up like we did in part A and rewriting them as 100A plus 10B plus C, I'm also going to have to make an assumption that, so we can tell which one's bigger by noting, is A less than C. That's really all that it's going to come down to. They have to be different, so one of these is going to be less than the other. So we'll start off by saying that. Since the digits are unique or distinct, we must have either A less than C or C less than A. We'll assume, and you could say something fancy like without loss of generality, but I would generally leave that to the real mathematicians. But basically it just means that we're just going to make an assumption it actually won't impact anything, because if we do the exact same work that we're about to do with C less than A, everything will work out the same. It's just a name change. So we'll assume that A is less than C. Therefore, ABC, and we'll keep their underline notation, is less than CBA. So RST is going to be CBA minus ABC, but that's 100C plus 10B plus A minus 100A plus 10B plus C. Now notice that the B's go away. 100C minus C is 99C. And A minus 100A is 99A. So we're going to get 99C minus A. Alright. So that tells me what RST is. And it's going to be a single digit. Like C minus A is just going to is at most A, or sorry, is at most C. How do we get TSR from here? That's the challenge. How do we get TSR? I think TSR should have to be something like 99A minus C or something like that. Well, hold on. We know we have to shoot for 1089, and I'm betting it's going to be a multiple of 99. Let's just see what multiple it is. So it's 11 times 99. So we know that RST is 99C minus A. So TSR should be 11 plus A minus C, if we follow that, because then we add those two up, it'll be 99 times 11, which is the 1089 that we want. That's what we're looking for here. So now it's up to us to show that that's the case. So I'll say something like, in order for RST plus TSR to be equal, I don't need to write English there, I can just write equals. 1089, we must show that TSR is equal to 9911 plus A minus C. I don't know how easy that's going to be, or even if this is the way to approach it, but that's what we're trying to do here. So I don't see an immediate way or an immediate reason why this should be true. So we're gonna move on to something else. So 99 C minus A is equal to RST. I guess I could write that as 100R plus 10S plus T, but then now we've got 5 unknowns here, and that makes me sort of uncomfortable. TSR is going to be 100T plus 10S plus R. And so we get numbers that I'm not happy with. RS and T, TS and R. Well, can I write this? Because if I can get unique digits that make this work. So this is 100 C minus A plus 10 something plus something. Right? So let's get rid of everything we've done, because I'm not seeing any of those methods going somewhere. So this is 99 C minus A. Well, that's the same as 100 C minus A, and this is going to be an actual digit, because C is greater than A, and C is at most 9, and A is at least 0. So this is going to be a single digit, minus C minus A. Now, the minus C minus A isn't the best thing for us, because, well, hold on, no, this isn't what I want. I mean, I'm shooting for sort of what I want, but this is 99 C minus A minus 1, if that's true, plus 99. And then, no, sorry. So what I'm thinking is, when I do 99, suppose this were 1, I'd do 99 times 1. Well, that's not 100 times 1 plus something. If I do 99 times 2, I get 198. If I do 99 times 3, I get 297? Yeah, 297. So whatever number I have here for C minus A, I do 100 times 1 less than that. Then, so break it up into steps. So this is 100 C minus A minus C minus A. But that's too big, it's too much for the hundreds. We shouldn't be subtracting, so we'll put it down by 1. Minus 1 plus 100, so that cancels out the minus 1 there. Minus C minus A. Okay. Now, I want to show that C minus A, C minus A can be 1, but it shouldn't be allowed to be 0. Actually, no, that's obvious. Of course, C minus A. So A is less than C. So C minus A is greater than 0. A is bigger than or bigger than or equal to 0. Technically, A should be bigger than 0, and whether or not that comes into play, we'll find out later. But so C minus A is less than or equal to C, which is less than or equal to 9. So C minus A minus 1 is a single digit. It must be from 0 up to, at most, 8. Someone might be able to argue that it's... no, I don't think it'll ever be 9. Right? Yeah, if that were 9 and 0, then you'd still subtract 1 from it. So yeah. Okay, so it's from 0 up to 8. That's fine. So we have an actual digit here. And then we need to show that 100 minus C minus A is something... It can be written as 10s plus t is really what we want. We know C minus A minus 1 is R now. That's fine. So 100 minus C minus A is... so C minus A is at most 9, so 91 is less than or equal to 100 minus C minus A, which is less than 100. So 100 minus C minus A is equal to 10 times 9, because it's in the 90s, plus 10 minus C minus A. And I think combining these two will get us our 11 or something like that. Okay. So this is another single digit from 1. It's somewhere between 1 and 9. I think you can probably remove the 9 if you start saying things like A has to be non-zero, but they didn't say A has to be non-zero, so I really, and they've even said sometimes zeros are allowed, so I'm just going to carry through, and I don't really care. I think the result should probably be true for 0 and then a 2-digit number where A is 0, but don't worry about that. So R is C minus A minus 1, S is 9, T is 10 minus C minus A. So we'll say 10 plus A minus C. All right. So RST plus TSR, that's 100 C minus A minus 1 plus 10 times 9 plus 10 plus A minus C plus 100 10 plus A minus C plus 10 times 9 plus C minus A minus 1. And I really hope this is all going to work out. So we'll have 100, the C and the A will cancel, so we'll have 100 times 9 plus 2 90s is 180 plus, and then again this is going to be 9. So that's 900 plus 180 plus 9, and that's 1089. Okay. So we're done. So that was B part. It took me a while to get it straight as to how I should be approaching it, and that's good. And question 4 should be challenging here. All right, but we're not even done yet. So we've got C. Suppose that n equals a, b, c, d. We've got a 4-digit integer, and we know that a is less than b is less than c is less than d. I bet we're going to reverse digits again. When the order of the digits of n is reversed to form the integer mn is increased by p. Again, the first digit of p is allowed to be 0. Okay, so the amount we increase can be 0. Okay, that's fine. In fact, if a is equal to b is equal to c is equal to d, then p will just be 0. Anyway, when the order of the digits of p is reversed, an integer q is formed. Determine with justification all possible values of p plus q. Okay, so it's like b, except we don't know the actual answer we're looking for. Just like in a, we increased and we knew the actual we knew the p value there. All right. So a is less than b is less than c is less than d. Well, let's get cracking. I'll flip the page. I want a bit more space to work with. But hopefully, having learned a bit, so we know that m is greater than or equal to n from our conditions. Okay, if a is equal to d, then both m and n are going to be equal. They're just going to be a. If a is actually less than d, then it's quite clear that m is greater than n. And you could probably write that argument out. I'm not going to because I want to move on to actually doing the question. So we'll figure out what m minus n is. And I think we're going to try and be careful and pick out digits like we had that c minus a last time. I think that'll be important. So this is 1000d plus 100c plus 10b plus a. I'm betting the difference will have 999s in there somewhere. So 1000 a plus 100b plus 10c plus d, and we take the difference, we get 999d. We'll even group the d and the a together, because that helped us last time. And then 100c minus 10c is 90c, and so we'll have 90c minus b. Okay, now both. Well, actually, let's rearrange it so it's actually the 4-digit number. So we'll have one less digit here, so we're going to say that this is 1000 d minus a minus d minus a. And then this is 1000 d minus a minus 1 plus 1000 minus d minus a. I'm going to say d minus a is going to be a single digit. I think we're going to have to make a choice, because if d is equal to a, then these guys are equal, so p is 0, q is going to be 0, so p plus q will be 0. So that's going to be a possibility, and then we can say d minus a is a single digit greater than 0, so 1000 minus that single digit will be 99 something. So in the same way, we're going to change the 90c minus b's, maybe? Don't know what to do with them. That's the problem. I guess we'll make it 100c minus b minus 10c minus b. And this will be 100c minus b minus 1 plus 100 minus 10c minus b. So the b and the c are really throwing us off here. And we had a nice little formula, everything was working out great, and then, or we had a technique, but now this, it seems inelegant. But again, c minus b, I think we'll have to make an assumption that b is less than c, that sort of thing. This is a trickier question 4. I feel like I'm spending a lot more time on this than I usually do on Galois 4. I can only imagine what the 2006 Hypatia 4 is going to be like now. Perhaps I'm just approaching this the wrong way. Probably if I kept the B, the D, and the A grouped together, and this was D minus A, 1000 D minus A, and so on, it wouldn't have been so bad. But if A equals D, I'm just going to write this because I'm a little stuck as to where to go with this equation, but I do know I've got to write this stuff out. If A equals D, M equals N, so P equals 0, therefore Q equals 0, therefore P plus Q is equal to 0. That's fine. So we may assume D minus A, or D is greater than A now. And so D minus A is greater than 0. So that'll be important for us. I think we can do the same sort of thing with C minus B, and then that will force this part here to be some single multiple of 10 or something like that. So let's see what happens. If B equals C, then all of these cancel out. Then so M minus N is equal to 1000 D minus A minus 1 plus 1000 minus D minus A. Of course, I'm running out of battery power. I've been going at this question for a very long time. Anyway, and then this will be something like 99x. And so we'll have a specific case here, and then we'll further assume that B and C are different from one another. D greater than A. Well, actually, we'll specifically say 0 less than or equal to A, less than D, less than or equal to 9. Tells us that 0 less than D minus A less than or equal to 9. So that means 991 is less than or equal to 1000 minus D minus A less than 1000. So P is going to be 1000 D minus A minus 1. We can also say D minus A minus 1 is greater than or equal to 0, less than or equal to 8. Plus 9 times plus 100 times 9 plus 10 times 9 plus 10 plus a minus d. Okay. Therefore, q is going to be, well, just reverse everything. 10 plus a minus d plus 900 plus 90 plus d minus a minus 1. And so p plus q in this case is going to be 1,000 times 9 plus 1,800 plus 180 plus 9. So 9,000 plus 1,800 plus 180 plus 9. And we'll just get out the calculator to speed this along. So that's 10989. So now we've got 0 is a possibility, 10,989 is a possibility, and now we can assume for all the other cases that B and C are not equal to one another. And so we'll get something different and probably even worse for me to work with. But we've got possibilities. So now we may assume B is less than C. We don't need to know whether or not A is less than or equal to B right now. I'm really hoping we don't have to get into that stuff, but so currently we've got P is 1,000, B minus A minus 1. I'm going to say similar to above. 0 is less than B minus C is less than or equal to 9, and 0 is less than or equal to B minus C minus 1. Sorry, it should be C minus B. C minus B, C minus B minus 1 less than or equal to 8. So we get 10 this plus 1,000 minus, so we'll even say 900 plus 90 plus 10 minus A minus D plus 100 C minus B plus 100 minus, so it'll be 10 times 10 minus this should be a C minus B minus 1. So this should be plus B minus C. That's a single digit. This is a single digit. This is a single digit. It's just these pesky 9s in here that are causing a problem. So we're going to clean this up. And then we should be done. So P is equal to 1,000 D minus A minus 1 plus 100, and then we've got the 9 plus C minus B minus 1 plus 10, and that'll be 9 plus 10 minus, or 10 plus B minus C plus 10 plus A minus D. Oi, okay. Now the issue here is we might get something carried. There might be a carry. So that's a few more cases. I imagine that it'll probably work out to being the same P plus Q in this instance, but I can't guarantee it. One thing we can do if we're looking for guidance is just do the procedure, pick like a random 4-digit number that satisfies it. So like 8731 minus 1378. So that's 353 or 7353. So I'll add on 3537 and see what other possibilities I'm getting. I'm getting 10890. So that's certainly something right there. So that's a possibility. We could play around and see what ones we get. That's just if we're looking for direction. I think this will all work out. I've got some cases to deal with. So this is going to be 19 plus B minus C. Is this guaranteed to have a 1 carried? So 19 plus B minus C. It certainly looks like it's guaranteed to have a 1 carried. And only a 1. So, so I know C minus B is bigger than 0, less than or equal to 9. So negative 9 is less than or equal to B minus C less than 0. Add on 19, we've got 10 is less than or equal to 19 B minus C less than 19. Oh, sorry, there should be a plus in here. So we carry a 1, and then P is going to be 1000 D minus A minus 1 plus 100 9 plus C minus B plus minus 1 plus 1 plus 10, and then we can subtract off the 10 from here. So 9 plus B minus C plus 10 plus A minus D. Alright, now those cancel, and we ask ourselves, okay, 10 plus C, or 9 plus C minus B. What can we have here? Are we carrying digits? Must we carry digits? So 0 is less than C minus B is less than or equal to 9. So 9 is less than C minus B less than or equal to 18. We carried a 1 because it's got to be, we could rewrite this as 1 less than or equal and then say it's 10. So now what have we got? Well, then we've got P is equal, we carry the 1 forward, D minus A plus 100, and now it'll be C minus B minus 1. Well, hey, we had that before. Oh, yeah, the 10 obviously brings it all forward. Plus 10, 9 plus B minus C, plus 10 plus A minus D, and D minus A is a single digit, so we're fine. So that tells me Q is 1000, 10 plus A minus D, plus 100, 9 plus B minus C, plus 10 C minus B minus 1, plus D minus A. So P plus Q equals, these cancel out and we get 10, so 1000 times 10, plus 100 times, the B's cancel out, the C's cancel out, 100 times 8, plus, again, these guys cancel to give me 10 times 8, plus, and now these cancel to give me 10, and we get, take out a factor of 10 everywhere, 1000 plus 80 plus 8 plus 1, something seems wrong. Oh, no. That'd be 1089 and then times 10, yeah. So P plus Q is 10890. Now we've exhausted all our possibilities, so P plus Q can only be 0, 1,989, or 1,089 up. These are my three possibilities, and I've exhausted all the options I could be taking here. Let's go back and double check. Yes, 10989. That certainly took a long time. I was definitely catching on by the end of C. There were just a lot more, just this digit carryover, and I don't think that probably really mattered. You probably could have just swapped some things around. But we got to be careful. It's the written one. We got to make sure that all our ducks are in a row as we're putting things on paper. So yes, we have to stop and carry. Unfortunately, there weren't cases of, if C minus B is less than 2, that it'll carry. So we only had the one situation to work with. Just so happened that everything carried over quite nicely. I don't have anything else to say about this. It was a good year. The 2006 Hypatia will be the next written contest I do. And, of course, that's grade 11 contest, the grade 11 multiple choice format, as well as coming up. And, so feel free to like or subscribe, whatever you want to do, and I will see you guys for more math contests in future videos. Until then, take care.